Good morning, ma'am. I'm Kit Galbanel, auditor from BSE 4C, and I'm here to report about the single and multi-stage self-priming pumps. So what are self-priming pumps? These pumps draw liquid into themselves without manually priming, ideal for above-ground applications. So single-stage pumps handle lower flow rates, while multi-stage pumps are for higher pressure and flow rates. So mechanisms of operation utilizes a unique design to create a vacuum that pulls liquid into the pump, enabling self-priming. So advantages of self-priming pumps, they reduce the need for a manual intervention, ensuring efficiency, ensuring efficiency. And then the common applications used in water transfer, irrigation, and industrial processes where liquid sources are below the pump. Maintenance best practices, regular inspections, and cleaning are essential for optimal performance and longevity of the pump. Understanding single-stage self-priming pumps. Single-stage self-priming pumps use one impeller to lift liquids, ideal for low lift requirements. These pumps create a vacuum to draw liquid into the casing, facilitating efficient operation. Design simplicity. The design of single-stage pump is straightforward, enhancing reliability and user-friendliness. Lower initial costs and maintenance due to the uncomplicated construction make them budget-friendly. Typically used in residential water system and small irrigation setups for efficient water movement. So for the next slide, overview of multi-stage self-priming pumps. These pumps have multiple impellers that work in series to enhance performance, generates higher pressures, and lifts liquid from greater depths. Suitable for high-rise building and industrial processes. Adds pressure with each impeller. Each impeller contributes to the overall pressure, which is critical for applications requiring elevated heights. More complex and costly than single-stage pumps. While these pumps are more intricate and expensive, their benefits in high-pressure scenarios are significant. Justified use due to the efficiency in high-pressure applications. The efficiency of multi-stage pumps in demanding conditions validates the higher cost and complexity. In the next slide, we will see the comparison of self-priming pumps, single-stage versus multi-stage. The first one is the number of impellers, one for the single-stage self-priming pumps, and multiple for the multi-stage self-priming pumps. The next one is the pressure generation, low to moderate for single-stage and high for multi-stage. Next is typical applications, residential and irrigation for single-stage, industrial and high-rise buildings for multi-stage. Then, the cost, lower initial investment for single-stage, then higher initial investment for multi-stage. Lastly, the maintenance complexity. The single-stage priming pumps is simpler, while the multi-stage is more complex. So for the next slide, the key benefits of single-stage pumps. First one is cost-effective. Lower initial purchase and installation cost makes them suitable for budget-conscious projects. The next one is simplicity. Fewer components lead to easier maintenance and repair. Next one is ease of use. Quick installation and straightforward operation are ideal for residential applications. The next one, compact size, typically smaller and lighter, allowing for more flexible installation options. Lastly, the reliable operation, proven technology with a solid track record for reliability in low lift situation. The next slide is the benefits of multi-stage self-priming pumps. The first one is high efficiency, designed for higher pressure applications, ensuring optimal performance in demanding conditions. Next one is versatility, adaptable to various industrial environments, making them suitable. Next is the increased lift capability, effectively lifts water from greater depths, crucial for industrial and commercial use. The next one is reduced system size. High pressure generation allows for compact piping systems. And lastly, longer service life. Constructed with durable materials resulting in extended longevity, and lower maintenance costs. For the next slide is the key components of self-priming pumps. The first one is the impeller, essential for creating flow by converting rotational energy into kinetic energy. Next one is the volute casing, guides fluid to the discharge, optimizing the flow and pressure. The next one is suction chamber, facilitates the suction of fluids, allowing the pump to draw in liquid effectively. The next one is check valve, prevents backflow, ensuring that the fluid moves in one direction through the system. Lastly, the motor powers the pump, providing the necessary energy for operation and fluid movement. Next slide, the applications of self-priming pumps. For single-stage self-priming pumps, it is ideal for residential water supply, irrigation systems, pool filling and drainage, and the wastewater management. For the multi-stage self-priming pumps, it is designed for high-demand application, providing high pressure and efficiency. The first one is the high-rise building water supply, industrial water treatment, fire protection systems, and lastly, the agricultural irrigation. For the last slide, understanding self-priming pumps. First one is the initial filling process. The pump casing must be initially filled with liquid for proper operation. The next one is self-priming action explained. The impeller spins rapidly, creating a vacuum to draw liquid into the pump casing. Third is the liquid movement mechanism. Centrifugal force generated by the impeller expels liquid through the discharge outlet. Lastly, continuous pump operation. Once primed, the pump can draw from the source continuously without any manual intervention. So that's all about the reporting of single and multi-stage self-priming pumps. Thank you for listening and God bless.